just give it 1 or 2 more minutes for people to file in. You can hear me, right? I assume so. Everyone's been very quiet.
Mic check, testing 1, 2.
Great, okay, thank you.
We can hear you fine. I would say, not only to David, but also to Chris.
Okay, thanks, Magnus. Dog has returned for the second meeting of the day.
It work?
Why don't we kick things off? Welcome everyone to the MASQUE meeting for IETF 110. Eric and I are pleased to have you here with us, even though it's quite early for us on the West Coast. Hopefully this is a productive meeting. Next slide, please. As a reminder, this is being recorded. I assume most people are familiar with Meet Echo, but if you're not, the button should be fairly explanatory in terms of how to join the queue, unmute yourself, and so on. As a reminder, please state your name at the mic if you have, or before you start speaking, so the note taker can log it accordingly. And as always, just please be respectful and courteous to others. Next slide, please. This is the note well. I assume most of you have seen this by now, given that we're already well into IETF week. But if you haven't, please take a moment to familiarize yourself with it, either here or online, and understand what it means to contribute to the IETF. I'd like to call it specifically the code of conduct. Again, just to encourage people to be respectful and kind to others. Next slide. Here's some links to help get you going. The agenda is here, although it's also listed from or pointed from the data tracker. We have a link to the notes here in the Java room. Before going forward, do need to pause and see if we can get someone to take notes. Maybe someone already has. No, it doesn't look like it. So we would be very grateful if someone could take notes. Should be fairly simple, given that this is recorded and transcripts are recorded. Any takers? It's very easy. Thank you. Whomever that was, thank you. Philip, thank you. Appreciate it. And if folks are, want to jump on the notes page and help them out, that would be greatly appreciated as well. All right. Next slide, please. So here's the agenda for today. just like to go through our primary working group documents, H3 datagrams, Connect UDP, and IP proxying requirements. And then, as always, as time permits, hopefully we can get to Tommy's draft on quick aware proxying at the end. I'd like to pause for a brief moment to see if anyone has any sort of adjustments or bashing they'd like to do before we kick things off. All right, hearing nothing, we'll turn it over, or we'll pull up the slides for Lucas and we can get going. Lucas, you need a mask hat, or you need a mask.
Well, you know, put your hands in your pockets, chaps, and you know, get going. I presume you can hear me okay. Is that a yes or a no? Yes, thank you,
Yes,
David.
go ahead.
So I'm going to present today about using quick datagrams with HTTP3, which we kind of interchangeably call HTTP3 datagrams, but I'm going to come onto that slightly in a few slides. So let's get started with the first slide, the 15-second summary of where we're at. We have adopted this document. So after I think the interim, we had some positive feedback about adopting this thing into MASQUE. There's a bit of overlap between this document and others, and it could have fitted into the HTTP working group. And we've had that discussion, but MASQUE is our home now, and this is where we're going to talk about stuff. So HTTP3 datagram is like a quick datagram, but the frame load must start with the flow ID. Anyone familiar with the history of where H3 datagram came from will know we kind of just shifted the flow ID from one place to the other without really moving it. But how it's used is changed, and that raises some discussion that doesn't need to take place here necessarily, but in the quick datagram draft. So I presume some of this might be discussed in tomorrow's quick session. So I encourage anyone interested in this topic to attend quick as well tomorrow. But anyway, ignoring that, what are flows? What's this flow ID thing? We kind of think of them as a logical bidirectional exchange of HTTP3 datagrams. And the main use case here is to support demultiplexing. So you would imagine an application using HTTP3 has different contexts for things, and it wants to support different flows and make sure that the right messages get read out or put in the right place. But to do that effectively requires some peer coordination. So you want to be able to, say, from a client, tell the server what a particular flow ID maps to. And so the way that we do that is to use HTTP messages to associate a message to a flow ID. Next slide, please. So just to remind people of the draft, this isn't like a question, but just to come up with some premises of the design and to assert that everyone's happy with them as a group for this adopted document. And so the first one of these is that all flows have an identifier, which is a value chosen by a flow identifier allocation service, as described in the spec. And that flow ID today is defined as a 62-bit integer in that range. So it's a non-negative integer. And when that's carried in a frame, so when it's carried in the datagram frame as its payload, it's encoded as a quick variable length integer. But when it's carried in a header, the datagram flow ID header, which I'll show shortly, we're restricted by the rules of structured field integer encoding. So there's a hard limit on that flow ID of 0 to 10 to the 15 minus 1, which is all written down, and there's some kind of quirks in that. We might change that. There's some open issues that we're not going to discuss today, but if anyone's interested, go to our GitHub repo and have a look. So next slide. And then the premise of 2 is that although this is called H3 datagram, we presume that there might be...
Lucas?
Yep.
Sorry to jump in. Should we maybe pause on the design premise to give people a chance to object if they disagree with it? Because I think it would be good to get working group consensus on that point.
Sure, I agree. Should we go back a slide and pose that question? Does anyone disagree with this design premise? How long would you like to wait, David?
I think that's long enough. We can move on.
That's good. Okay, back to this one. Yes. So the case here is that sorry, getting distracted. That yes, you can use quick datagrams when you're using HTTP3, when that's the application protocol you select, and you can use these flow IDs encoded in the payload of the quick datagram, and you can use that for demultiplexing. But we should support some applications that might not actually want that behavior. They might be comfortable with inventing their own demultiplexing layer. Maybe they want to extend things in a different way, or whatever. Like, we shouldn't close the door to people who might want to do things differently, although it's not our concern about how they do that. And the way that we can achieve this is via this H3 datagram setting, which allows the endpoints to negotiate that, when both opt into this feature, that they will use flow IDs as described in the spec. So yes, I think that's a good point to pause again and to ask people, are they happy with this premise? Does anyone object or have an issue with it?
First.
Ben Schwartz. Unless we have if we don't have a use case for opting out of this right now, can we define it later when we need it as an opt-out?
Jumping in as co-author to answer Ben here. So this document changes the semantics of HTTP, as in HTTP3 by default, the datagram frames aren't to be sent. And so if we want to give them semantics, which we do here by, like, for example, starting with a flow ID, we need a setting. That is like how HTTP3 works. Because some other extension later down the road could say that the datagram frame in HTTP3 starts with an emoji, for example, or something silly. And so if we want this, we need a setting. That's kind of how that works.
Okay.
Do you do that?
It's not entirely clear to me that this is true, but I can believe it's true if you want an answer to your datagrams. That if you're not content to just throw them across the wire and see if you get something back.
Yeah, but you shouldn't be sending something across the wire unless you know that it's not going to break the other side. If you send something and the other side says you're not allowed to send this and closes your connection, you're going to have a bad day. Yes.
So that's another question. Like, if you start firing quick datagrams at some H3 endpoint that's never heard of them, what happens?
Right now it's undefined. So that endpoint could close the connection, it could crash, it could email your private keys to the NSA, and that's why we want to define it.
Okay, got it.
Yeah.
So this is not proposing a mechanism to define other rules. This is just noting that somebody could. Thank you.
Absolutely. This is saying is in order to tell the other your endpoint that you are conformant with this document, you have this setting. That's all this does.
Yeah, and just to add, we have the transport parameter negotiation for the quick datagram, but just receiving that doesn't help because, as David said, it's completely undefined what receiving a datagram should do. And I would say, based on my personal past experience of, say, trying to deprecate a default feature that wasn't negotiated via a setting, as in the form of priorities in H2, has its own challenges too. So trying to turn something off after the horse is bolted is kind of harder than it seems. So I personally, I support this premise, but I think it's good to have this discussion.
You're up. It probably cut me off. Alex, you're up.
So I have a quick question about the one other rules for using quick datagram frame payload feature that you're mentioning there. I'm totally in favor of having the settings to say we want to turn this feature on, but the use case of other applications might not want the demultiplexing seems like a anti-feature to me, because you could always use a very low flow ID and therefore only sacrifice like 1 or 2 bytes. And I feel like in terms of compatibility, we might want to say that the flow ID is mandatory, and if you want to put everything on one flow, that's up to you. And I would prefer that design, because then it means that we can multiplex multiple things over the same H3 connection, some of which may want to do their own demultiplexing and some of which may not, without having to tie the fate of the entire connection.
Cool. I think that's a valid view, but personally, I think just because we have this setting as it's stated, it doesn't add any complexity to our specification to support any case where demultiplexing might be needed. Someone later could come along and define a new, extension to HP3 that effectively supersedes this, and people could be free to negotiate that and do what they want if they didn't want to eat this kind of short flow ID. I'm not saying I would do that myself, or I can think of someone who actually would, but I don't want to constrain other extensions that might exist.
I understand what you're saying, but it leaves me uneasy.
Mike, go ahead.
I
think you wanted video there rather than screen.
Yes, I accidentally was trying to screen share. So just first off, wanted to point out that H3 does not prohibit datagram. There's no such frame in Quick v1. Therefore, H3 says nothing about it. They just have no defined semantics. But the thing that H3 does have, and H2 as well, is kind of a difficulty with negotiating things with the peer. You advertise statements about your capability and then have some rules about what you do with those sets where they overlap. So let's say that something could do this type of H3 datagram and could do something else. We would have to define rules for how you advertise the set of things that you can do and what happens when both of you support more than one. And I don't think we want to wade into that mess here. That makes me sympathetic to the, just do you support datagram or not, and they always have the flow ID. And then you just have to figure out how you allocate flow IDs, how you reserve them. Otherwise, we're getting into defining negotiations and IANA registries, and we don't need that right now.
Just to jump in, I'm just from the questions seeing a bit of confusion. I think that maybe that first line on under the title in this slide is a bit confusing. All we're trying to say is this setting tells the peer that you support the specification. That's it. And that's how we've understood like the mechanisms of defining semantics in HTTP3 to work, because if something doesn't have semantics and we give it semantics, we need to make sure that the other side understands those. That's all we're saying. We're not suggesting any complication or ways to demultiplex other applications here.
Yeah, I agree with that. The issue is when you start talking about what other applications might or might not want. If you support this and something else that can use datagram, the meaning of that is almost as undefined as not sending anything.
Oh, I totally agree. I think that is completely out of scope and illegal. The idea of the setting here is if later down the road someone says comes up with a better design, they could not send this setting and send another setting, and they would have their own different datagram thing that is completely incompatible with this one, but the connection would only use that one. I do not foresee any use for two of them at the same time, because that is a huge can of worms that we do not want to open.
Mm-hmm. Yeah, the trouble is if you then want the ability to negotiate down to this one with your peer. But that, I agree. Let's leave that problem for another day if we have to have it.
Tommy?
Tommy, go ahead.
Cool. Yeah, so just echoing what a lot of people have said on chat already, I think we need to use the settings. Just how it is I believe the correct way. I think it's more for future proofing. Also, to be very explicit that the H3 application is intending to do this. To some of the earlier points of, why do we actually need this, or how would we use the negotiation versus not? On the Connect UDP draft, there's a conversation we're having on one of the issues around if, like, how like stream chunks could work and if they could share flow IDs with datagrams. And effectively, this setting would be very, very useful there to know for sure, does this hop at the HTTP layer support datagrams? If it doesn't, you interpret Connect UDP differently. I'm not saying that's necessarily where we're going to go, but that is an example of why you need the setting. Because you could have an implementation that your quick layer always advertises that it supports datagrams, but your H3 application on top at the moment does not, and you don't want to have to force that coordination. So I think we just leave it as is.
Jonna?
I'm trying to come up here. Yep. Well, I want to jump in to echo some of where I think the conversation is on chat, but I really want to say that let's not over-engineer this. And I want to say this now because I want to say this for subsequent design premises as well. We want to build to the use cases we have right now. As long as we don't block other use cases from happening in the future, I think that should be good enough. And this one clearly does not block us from doing other use cases in the future. I want to see an H3 datagram new, and then a newer and a newest datagram settings in the future. I don't want to preempt those now. So yeah, I think this is fine. This is great. If we want to change the semantics of what H3 datagram means, we can redefine, we can define newer settings in the future.
Thank you.
Martin?
Hi guys, David, a long time ago you articulated the desire for mask servers or mask proxies, I guess, to not freely advertise their capability. And I wonder if this is an unavoidable effect of this design that, I mean, unless servers are withholding settings until the client sends settings, that H3 datagram could be a clue that the server has mask capability.
So I totally agree with you. I believe very strongly that mask capability should not be advertised. And the key property there is that it shouldn't stick out. So my solution to this problem is Google will send this on every single quick connection, HTTP3 connection. And if we get everyone to do that, then we don't have this problem. Because all we're saying is we wrote some code to support HTTP3 datagram. We're not saying that we're actually going to let you do Connect UDP. We're not going to let you do Connect IP or whatever cool things Mask sums up with in the future. We're just saying we have an HTTP3 stack that happens to support datagrams. And if enough of the open source, or it doesn't have to be open source, enough of the widely deployed implementations do this, then this doesn't stick out.
Okay, I mean, obviously, if other H3 datagram applications become very popular, then this is going to be, then I don't think there's an issue here. But if like for whatever reason web transport's kind of a dud, then and Quick is, I mean, and Mask is the dominant application here, then I think we have a problem for people who are not as careful as you. And I don't know if we need to put something in security considerations for Mask to kind of call that out. And the mitigations like withholding settings, etc.
That's reasonable.
Yeah, I think that's good feedback. I'd just say that like having this feature on doesn't mean that the server needs to do anything. Like you can reject any request that you want in HTTP. And that's one of the benefits of actually tying the usage of datagrams to messages. We can just benefit from all that prior work.
Christian.
Can't hear you, Christian.
You're muted, Christian.
I saw that the hand tool was unmuting your microphone, but
it doesn't anymore.
Why? Okay. It was pretty much the same question as Martin. I mean, I am very sensitive to this privacy issue, and I know that there are guys out there that are running bots to find whatever proxies they have that they want to shut down or block. And so having a big sign that says, hey, I am a proxy right here in the setting is not without consequences. And so at a very minimum, I mean, David's answer shall be expanded as a privacy consideration in the security section. And that's a very minimum. My actual desire would be to be able to renegotiate the setting once the user is authenticated, but that's probably harder.
It's a lot harder in H3, which doesn't let you send settings after the handshake.
But I'll definitely mention this in the security considerations section, and totally agree with you.
Okay.
All right, thanks all. It sounds like we're mostly in favor of the design premise on the previous slide, so note that, potentially update the security considerations accordingly, and move on.
Cool. So this slide is just stolen from David, I believe, from some previous talk. I don't know which one it is, but basically, if we're happy with the concept of flow IDs, then we'll want to discuss what the values are, the values that we use. And so on the left-hand side, we have a simple approach, say, that given that this flow ID is associated with a request, we just go for a simple one-to-one mapping. We use the request stream ID as the flow ID that would appear in the datagrams. There's some downsides to that, mainly on that one-to-one mapping. Due to the unique way that streams are used in Quick, we can only benefit from a quarter of the available ID space. So we might have some longer encodings and some overheads, which is not a huge downside, but for some people it could be. And on the other side of things, we've got not a one-to-one mapping. So we have what we identify as a distinct namespace, so that we can allocate flow IDs in this namespace separately from the request streams and the IDs of those request streams that spawn those flow IDs. So in order to do this, we've got this flow ID, datagram flow ID header. The use of the flow ID is explicitly negotiated using that header. A client would send this header in the request, say for a connect UDP request as just an example, and the server would echo that value back to confirm that that flow ID is fine to use. And the benefit of doing this is in this decoupled way is that it supports a many-to-one mapping. And I've got some slides following this that will explore that a bit more. So you don't need to rely just on your imagination. There's an example of how this is used in the notorious poorly masked quick proxy, which we never seem to find time to talk about. So I hope we do today, because that'll give you a better impression of things. But yeah, the authors, the specification uses this right-hand design at the moment. And again, we'd like to double check that's the right thing to use. And we have some opinions on why we think that is better. But no matter what, we need to pick one because other drafts depend on the decision here. So if we go on to the next slide. the discussion here really boils down to multiplicity and what people might like to do with datagram. So, the simple case that I just mentioned, the one-to-one stream, one stream to one flow. This is like the minimum that all implementations of H3 datagram need to support. There's like no point of having one stream to no flow. That's just normal HTTP, and there's no so that you can have a flow without an association to a request. So option one on this slide is what we have to do. And then there's additional things that we can do that might have benefits of some use cases. So you could have streams referring to the same flow across different HTTP requests. And you can see Tommy's draft for that. And then there's another case where we might want one stream or one request to establish multiple flows in kind of one trip. Again, this would work the same as the client requesting for those flows to be created, the server echoing back all of those flow IDs to confirm that they're supported and that they've been created. Or perhaps it can't create all of them because of an extension that I'll show in the next slide. And it only confirms some of the flows that it was happy to create. And so to support this multiplicity in the last version of the draft,
Lucas, sorry, again, maybe let's take a moment to talk about whether we want to do multiplicity or not before we go into the datagram format, if that's okay.
Sure.
So the question kind of for the working group here, and actually if you could go back to slide 5, is so far we've seen two designs. One is what we currently have in the draft, which is to say there is a namespace for datagram flow IDs, and you allocate them, like the even ones are client, the odd ones are on the server, and then you exchange them via header. That gives you enough flexibility that extensions can decide to do many to one or one to many. There is another design that is slightly simpler, which is to just use the stream ID. That is a lot more constraining. It makes Tommy's extension not work, and from implementation, we know that it's not that much simpler because we got interop with 4 implementations on the datagram flow ID design. So what we'd like to do in this session, and I mean, I'll let the chairs handle that, is reach ideally consensus on one of those 2 approaches so we can put that to rest and move on. And one last thing I'll also say is the current design in the draft, which has its own namespace, is designed in such a way that if an implementation wants to only use the request stream ID, that actually works. Because the fact that the 2 namespaces are technically different doesn't mean you can't reuse the same value for both. So if someone for some reason thinks this is too complicated to implement and wants their datagram flow ID allocation service to only ever return the exact same value as the stream, they can totally do that. And so that's why I'm personally pretty strongly in favor of this more extensible design that is only marginally more complex. But we'd really like to get everyone's take on this so we can discuss it and then ideally reach consensus. Should we start with the queue? Ian?
Specifically, just to echo what David's saying, we'd like to know whether or not we should basically stick with what's in the draft right now. And we'd like to really nail this down. Of course, we'll confirm on the list, but let's have the discussion now. And
Cool.
With that, Ian.
Thanks. On this particular slide, I think I want to call it first. On the left-hand side, the 25% of available IDs, I mean, you could fix that by dividing by 4, so I'm not sure if that's actually a germane comment. And then the other one I was going to say is that reusing flow IDs is, I would say, an actively harmful idea. I think this might have been pointed out in a prior meeting. We should not do that if we do the datagram flow ID header. I prefer simpler if we can get away with simpler. And so I think, unfortunately, I need to see the rest of the presentations because I haven't read Tommy's most recent draft recently enough to swap in why the extra complexity is necessary. I have read David's draft on ECN. In that context, I don't think I like using multiple flow IDs. I think there might be other designs that I prefer, but maybe either I can quickly read Tommy's draft during this meeting, or the presentation will make it obvious. So I guess I need more information, but I would like to really be motivated that we really need this extra level of interaction.
So yeah, we please read the drafts, and if you have points about complexity, the code base that you and I share supports this, and it's about 10 lines. It just uses a UN64 on the quick session object. So I would like to hear statements about why people think this is complex.
Tommy?
All right. So, I definitely support not making the identifier that goes at the beginning of the H3 datagram have to be a duplicate of an identifier that comes from a quick stream. Partly just for layering there. But I want to challenge us to kind of rethink how we're framing this. In the discussion that we've been having around, okay, what are the different uses for these flow IDs and why you would have multiple? Not talking about the quick aware proxying, but like looking at the ECN example. Essentially, there are two ideas being brought up there. Like one is we have a flow ID that represents, okay, this is ECN marking of this for this connect UDP stream. The other flow ID is ECN marking that means this for this connect UDP, for the same connect UDP stream. The other way to do it is to say you have the stream ID from the original stream as the first integer that goes into the datagram. And then after that, you have this other number identifier that you choose as like an ECN specific marker that says, okay, everything from here on is this flag or not. What I would, and similarly, when we're talking about like the stream chunks in Connect UDP, we have a question of, do we use like a new namespace for stream chunks, or are we using datagram flow IDs? And I would challenge us to say that we don't really need datagram flow IDs at all. That these are not actually identifying streams fundamentally. Like, there's kind of a reason we didn't put the flow identifiers into quick datagrams itself, because it's totally up to application interpretation what a given message means. So at the end of the day, all of these use cases, I would argue, whether it's normal Connect UDP, whether it's ECN, whether it's quick aware, don't really care about a flow of datagrams. They care about some application defined meaning for a given message. And that meaning may have nothing to do with a quick stream identifier. That tying ourselves to saying that this is a flow that we should think of as a quick stream, I think is pretty limiting. And we could just say, nix that field and call it, your message group identifier or whatever else. It's not really the same thing as a stream.
Luke, unless David or Lucas, you'd like to respond to that.
I'm just totally in agreement with Tommy here.
All right, I'm Luke. I think it might help to draw some parallels here. In my mind, this is in UDP land. This is close to how RTP and RTCP works with the different flows in the same connection, where they just have one port for RTP and another port for RTCP. And that's fine. Like, you could have that. If you were using MASQUE for that, you'd set up a header. You'd say RTP is this flow ID and RTCP is this other flow ID. If you wanted to reuse the shared connect. Or you could go a route where you kind of have the MUX together. As I know WebRTC does a lot today, where it's using a single port. So I don't think it matters too much. I would like more examples where it's useful to have multiple flows in the same connect request. Because you can always, there's always like an alternative, like wrapping, whoever just mentioned is another way, or yeah, I don't know. It seems like there's not really a requirement per se to have multiple flow IDs.
So to answer your question about examples, the way I think about it, and we'll discuss this a bit further in the next presentation about Connect UDP. Often these features, the lifetime of the feature is tied to the stream. So that's true, for example, in Connect UDP. When the stream gets like reset, you close your target bound UDP socket, for example. And in Web Transport, there's kind of a similar idea where a Web Transport session has a bunch of streams, has a bunch of datagrams. If the stream that established your Web Transport session gets killed, that's when you clear all your state. So lifetime is important, and I think it's important to tie lifetime. So let's say, for example, so I'm not an expert in RTP, but when you have a protocol that requires two sub-protocols to work, it is really useful to tie their lifetimes together, because if one of them drops and not the other, that's an extra complexity you need to handle. So to give you an example, and that's something that, like, not, again, this is an example, so don't jump into the solution solving of this, but if and when we build Connect IP as part of this working group, let's say we have a flow ID that is, okay, here are regular IP packets, and then we have a compression extension that is, oh, by the way, if the IP header is exactly this, you can just send this flow ID instead, and then just the IP payload. Again, this is a VPN tunnel with optional compression, and you want to tie the lifetime of those two things together. So in my mind, you want them to share one stream, which is responsible for the lifetime, but then you want sub flows of datagrams. So that's how I see an example of why this is useful. Like you said, all of these are at the end of the day isomorphic. You could instead say you get one flow ID and then you add an extra layer of demultiplexing after that. I think that would be unfortunate. So that's why I think like this model is simple enough, but powerful enough to allow all these extensions.
All right, so we're going to cut the queue at this point. It looks like this is probably something that needs a lot more discussion, most likely on the list. So for the people that are remaining in the queue, if you have particular comments that you'd like to weigh in that you could be brief about, please do so. But to make time for the rest of the presentations, we'll take this to the list when done. Alex?
I just want to add and address something that Tommy said. I actually feel like this not being in the quick standard was actually a mistake. And I do think that we need this concept. And I think the thing which probably is up for discussion is whether or not flow ID is the right term. But I do think that we need some capability to be able to distinguish whether or not a bunch of datagrams are to be used in a particular purpose. Otherwise, you can't multiplex within Quick multiple things which are using datagrams. So I think that we do need this extension point, and if renaming it is something that makes people more comfortable with it, then we should possibly look into that. Like, for example, I would love to be able to have WebRTC and a Connect UDP connection going over the same H3 thing. And we can't do that unless we have a way to identify them without requiring each individual implementation do something different, and do that demultiplexing that David was saying would be unfortunate.
I'm not sure I understand what I get what you're saying, and I think, being able to multiplex different things over one quick connection is important. But are you saying, in the specific context of this question, are you arguing for a particular solution? Because I think what you're saying is we need an identifier at the start of the datagram, and I think everyone agrees on that one.
Yes, and I was mostly wanting to address something that Tommy was saying, where he was saying challenges to figure out whether or not we even need this. And I think the answer is we absolutely need this. The argument that it wasn't included in Quick is not a strong one. The specific choice between what is simpler here versus not, I think, is in the eye of the beholder. I actually personally think the distinct namespace is simpler if I were to make an argument. But I think that the concept that we need to be able to identify this, it probably should have some sort of way to be bound to a stream per lifetime. Whether or not that's mandatory or not is to be discussed.
I think we're in agreement there, and I think you might have misunderstood what Tommy was saying, but Tommy's back in the queue, so I'm going to let him say that.
Could you just clarify which of the two you said was simpler for the note taker?
Alex, can you clarify which one you said was simpler?
I personally feel the distinct namespace option is simpler because then I don't have to think about what happens if we like mismatch them. So I actually disagree with the reuse being marked as simpler.
Yeah.
Cool. That's good to clarify. Yeah, and to clarify the comment around why Quick doesn't have it, I'm not trying to use that as an argument for why it needs to be here. It's more that fundamentally this field only has meaning from the application semantics that are defining how it wants to communicate a given message. And that's, so in Quick, a stream is identified by something that has transport level properties. And I think really here, the only way we can decide what an H3 datagram means is based on the header fields that come in an HTTP request that first define that value. And so for connect UDP, that's going to be used in one way. Web transport is going to use it in another way. And extensions to connect UDP can use them in still other ways. And these are all really unique to whatever semantics those header fields have. So I don't think this document needs to create preconceptions around what this essentially arbitrary set of bytes at the beginning of a datagram means.
Okay. So we have drained the queue now. What I'd like to do very quickly before moving on then is just do a quick show of hands to see where people are sort of leaning either left or right in terms of reusing stream ID and matching it to flow ID or using the distinct namespace. So what I'm going to do is throw up a show of hands for option 2 and give folks a quick moment to fill that out. Should see it now. Tommy, you're still in the queue, by the way. Did you have something else to say? Okay, never mind. Okay. So end session. Seems like people are mostly in favor of this. Now I'm going to flip it around and ask the opposite question. There you go. I feel like there should be music to go with these show of hands.
Well, you could whistle the Jeopardy theme.
Can't whistle. Besides, the dog is louder than my whistling.
The royalty-free version.
All right, so it's more or less the exact opposite. So that, I mean, that looks like very clearly it's pointing in one way, which is option 2. We will we'll confirm this sort of consensus on the list, and with that, I think we can move forward.
Chairs, how are we doing for time? I'm just aware there's other presentations here, and I think some of these slides effectively depend on the outcome of that further discussion.
How many slides do you have left?
There are 12 total, so 6.
David, I'll guess put it over to you. How much time?
So what I would personally suggest is I think the most important questions we have for this session is kind of nailing down, the WAR format. And I think, like, for example, this call we just had, I would say, Lucas, it would be nice to spend the time we need on the datagram flow ID header, because since we'll confirm this on the list, but if we assume that the list matches what's happened in the room, we need the datagram flow ID header. So maybe let's go through all of the ones about the format of the header, because I think it would be really useful to nail that down today. And then on the other issues that are a bit more niche, maybe we can punt on those for today. That's what I would suggest.
Yeah, I mean, there's only one other issue, and that's around the flow ID reuse. So let's just see how we get on. Just chairs interrupt me.
Yeah, I think in that one, I get a sense that we're going to close that one in 30 seconds. So maybe you go through all your slides, and then we'll see how it goes.
Cool. So we've talked a bit about multiplicity. I want to stress that the concept of a separate namespace for flow IDs is slightly tangential to some of the multiplicity that we're going to be talking about here. It would be possible to have a flow ID header that only lets you send one value in it, and so that's something we need to bottom out as well as part of this discussion. So if you go on to the next slide, I think people understand the multiplicity at a base level. But what we have is an ability to send multiple IDs that are integers, and what the draft currently says is that it kind of tries to describe that these flow IDs, you have this minimal, you always have to support one, otherwise there's no point in trying to negotiate it, but that you might have more, and that those extra flows are kind of in support of extension behavior that may or may not be supported at the peer you're trying to negotiate the extension with, and therefore we want to give those flows a name or some handle that the other side can look at and think, I don't support that parameter, I'm therefore effectively going to ignore this entry in the list, and I'll just respond with the mandatory flow if I was going to support that. Under the hood, this thing looks like just a name, but it is a proper structured field parameter, although I see in the comments that the syntax isn't just one, it's a question mark one. But the gist is it's bool, and if you care to look, it could look like that. And that's what the spec says today. But we have an open question based on the interim discussion that this maybe isn't completely straightforward and doesn't necessarily support the extension cases that we had in mind. It doesn't articulate them very well. So if we go on to the next slide, we have on the GitHub repo issue 24, which just says parameters should not be named. So this is opened by Tommy, and to kind of paraphrase or summarize what he said there, in order to use parameters more conventionally and to clarify what the spec's current design is trying to achieve, and to clarify that the design allows additional parameters other than just this weird name thing, that we could do something different. And there were two suggestions on that issue, along with another alternative that is more detailed on the next slide. But just to go over these, suggestion one is that rather than have like unnamed parameters, you define an extension point, say in this case, like a Rick asked the extension point, where you would say for these different flows, as part of the extension, these are the kind of characteristics of that extension that I want to send different messages on in this connection. And if you don't understand that extension at all, you don't understand the parameter, you would ignore it and deal with it effectively. If you did understand the extension, but maybe not one of the extension code points here, again, you can deal with it. Suggestion two here is very similar but slightly different in that you wouldn't split the extension code point into specifically Rick Astley and sub-extensions, but you would have just this common name parameter that we would define in this specification, and then allow extensions to have a name. And again, whatever the endpoints are doing to determine if they support extensions or flows, they have something obvious. Basically, an implementation needs to look at this header and decide what it supports, what it wants to do, and what it can echo back to the peer that instigated it. But there's another alternative that's come up that isn't on the issue itself, but is worth describing. So if we go on to the next slide. From the basis of what we're trying to achieve, this alternative is trying to say that we coin not only this effectively like extension parameter name and value field, but also a default parameter that could appear on any flow ID that is expressed in a header. And the purpose of this is to state that, or to make it easier for an endpoint that doesn't understand any extensions to kind of effectively strip them out, ignore them, and just look at that list of flow IDs and easily identify the default flow that the peer was trying to request. That potentially makes it less ambiguous and easier to do. And so in this example, we talked about an ECN extension. And you could see if you don't support ECN, like most people, you would just ignore that parameter and pick flow ID 42 in that first example. The benefit of this kind of design is that it allows maybe a better composition of extensions. That seems a bit controversial given some of the discussion earlier, but that we can use this combination of evil and recastly to come up with different weird combinations of stuff for different flow IDs, but have a very clear ability to select a default, which I think is pretty unambiguous to anyone who would just look at this and read it on spec. So if we go to the next slide, or have we got some questions?
Yeah, you got 2 questions queued up. Start with Martin.
So Lucas, I think what's unstated in these 2 slides has been the point that in the first one, you sort of have to understand the name of the parameter and the value of the name parameter, depending on which option you have, in order to make any sense of this particular item. And the assumption there is that if you see something there, is this the sender saying, is the sender of the header the receiver of the flow ID, or is it something else?
So let me maybe try to explain here. The idea is that, so we have a list, so there can be multiple flow IDs with this one stream. And then the receiver, so let's say the proxy in this case, will do different things with these different flow IDs. So for example, one of them means a different value of the CN bit in the header. The important distinction here is it's possible that the proxy doesn't understand the extension. And we want it to, let's say in the example of an ECN extension, you want that to grace.
Back up a bit.
Okay.
Back up a bit. Is this the client saying, use flow ID 46 for ECT1 markings when you send packets to me or send datagram frames to me? Is that what it's saying?
Yes. And it's also actually, it's saying
That's
2
all I
things.
needed
It's
to know.
saying, if you want to send it to me, use this. And also, if I send you a datagram with flow ID 46, that's what I'm trying to tell you. It's bidirectional.
But the server would have to echo that in order to acknowledge that it supports that. So these are both unidirectional advertisements. It's like the STP thing. If you send me this thing, I will interpret it as this, and so on.
Totally agree. The server echoes this, and actually that is a bug that we just found out. Right now, the echoing is in the Connect UDP document. We want to bring it down to this one because you're totally right. We need that. Right. So yeah, we didn't state that. That is kind of the assumption of what these are for. Yeah.
Yeah. So I think the default thing doesn't make any sense in that context, because what you're asking someone to sign on for is, if you don't understand all of these other things, just send here and that doesn't really give you any knowledge about what you've just signed on to the semantics of. So you've signed on to saying that this is not ECT, but you didn't understand the ECN parameter anyway. And so you're going to be sending these packets. The client's going to go, oh yeah, fine. These are not ECT packets, but well, some of them were not ECT, but some of them were ECT 0, and the server didn't know.
Well, so here's what we mean. On the and again, just using ECN as an example here. Let's say I'm doing a connect UDP from the client to the proxy, and I'm going to start sending some packets. The proxy doesn't support the ECN extension, so it's going to fall back to regular connect UDP, and it's going to pull packets out of a UDP socket, not know what the ECT markings were on them. And when it turns around to put them in a datagram, it needs to put them on the one that means not ECT.
Yep.
And
I totally got that.
Yeah. No. And so then the question is, we need or unless I'm misunderstanding, I think we need a way for the proxy to know, okay, which of these 4 numbers should I be sending to you? And initially in the document, it has a name. Okay, sorry, go ahead.
Sorry, I was making a different point, which is that now the client and the server don't agree on the semantics of what the contents of those datagram frames, because one of them understands ECN, the ECN parameter, and what that means, and the other one doesn't. And you're allowing that mismatch to occur.
I see Martin's point. I think if we were to go with this route of a design, I might just suggest that implementations have a default that is like not tied to any extension, just a plain datagram. And if they can't do that, if they really need to, then they shouldn't be expecting to have wide interop on the internet without some form of alternative negotiation here.
And that's kind of what we're seeing, Martin, is that for the ECN extension, not ECT is the same as this extension doesn't exist. And so that's what we want as a graceful fallback. You don't want to do a connect UDP request with ECN and then go, oh, I don't speak ECN, and then have to do a different connect UDP request without ECN. You just seamlessly say, okay, I don't support this, and we're just going to use one flow ID, which is the default one, for UDP packets, and they don't carry ECN semantics.
But you accomplish the same by not marking 42 with anything. Right, don't you?
Yes. Oh, so then that's one of the things I was thinking, and here's another wrench thrown into these gears, is imagine you have another extension, which is like timestamps or something, and you have this ECN extension, and then you have this other extension that's on all of them. Then you don't know which is which, and that's why actually Tommy came up with the idea of a default one, which is okay, I have no idea what's going on, and I don't want to do these two parameters I don't understand, so I'm going to clear them and all that. Oh, I just look for default, I go with that. It makes parsing a lot simpler.
Yeah, but the timestamp one's an excellent example. So the timestamp one says, if this parameter is present, the front of the packet will have a 4-byte timestamp added to the front of it. Now, the endpoint that's sending that information is not adding that 4-byte thing because it didn't understand it. And you've got interoperability failure. So this seems like the wrong design to me. That's all.
Okay, so just to make sure I understand you, if we were to say extension that want to use multiple flow IDs and fallback gracefully must have one that does not carry any parameters, would that make you happy? Because that is an alternate design which I think would work.
You don't have to use the word must. You can just say, if you expect it to work, then this is a pattern that you're going to have to follow. Otherwise, interoperability failure.
So in that case, so in the looking at this side, we remove default and we just say, if the ECN parameter is not present, it means not ECT. Do you think that would be a good design?
For ECN, assuming that we go with the ECN design, yes, that would be fine.
Cool. I'm totally okay with using this design. Victor?
All right, we're gonna cut the queue here and see if we can narrow ourselves down to a set of options as we try to wrap things up.
Can you hear me?
Yes.
Yes.
Okay. I was gonna ask a clarifying question. So my understanding was that the purpose of datagram draft is define how to multiplex multiple flow of datagrams over HTTP3 and how to manage their lifetimes, correct? Am I correct?
That is one of the purposes, yes.
I'm mostly observing that the annotations do not really seem to have to do anything with this, and they more seem to do with specifically mask semantics. So I do wonder if they belong in this header or they should go to a separate header. Because if you don't use any of those, this makes parsing datagram flow ID much more complex, whereas normally you would expect to be able to just use strsplit and convert them to integers.
So that's a very good question, and we should have clarified that. The reason this needs to be there is intermediaries. The datagram flow ID is a special header in the sense that intermediaries are expected to parse it because datagram flow IDs are a per quick connection concept. So if you have an intermediary between your client and your ConnectUDP proxy, it might use a different datagram flow ID on both legs there. And so the intermediary needs to be able to parse the datagram flow ID header because they might rewrite those numbers. And therefore, the added extensibility information is in a parameter there. So when the intermediary rewrites those, it takes the parameters as an opaque string, doesn't do anything with them, and leaves them there to go upward. That's why it's part of the same header as opposed to a different one.
I think I understand. I'm not sure how much I agree with that, given that I've not thought about alternative approaches to solving that problem. But thank you for clarifying that.
Cool, thanks. Maria? And Christian, I think they cut the queue after Maria.
Yeah, so looking at this example even more, I think you're overloading the signaling of the flow ID with actually negotiation with an extension, and you also put like part of the semantics of the extensions into this scheme here. So basically all you need to know to follow this exact same scheme here is like you have a base flow ID of 42, and then both ends understand that they know what the ECN extension is and how to use it, and then you could just say, you know, these 2 bits of the flow ID are now the ECN field, or the last 2 bits, or we add another 2 bits after the flow ID or whatever. So all you need is really to make sure that both endpoints understand the same semantics, and that means you just have to have a negotiation for extensions. And by doing it this way here, this is a little bit error prone, because what happens if you don't like specify all the semantics fully, because you have like these 4 bits and you need 4 different streams for 4 bits, and if you only specify 2 of them, then you don't really know what to do here. So I would really rather separately things out and have signaling of the flow ID separate from negotiation of the extensions.
So, I mean, if you have an alternate design, I would love to see it. But this design came to be because I couldn't come up with a different way that would work in the presence of intermediaries. And I think with we can add that on a slide later. With MT's proposal, we end up with something simple, which is extensions can use parameters, period. The base document here doesn't need to specify any of the semantics of the parameters, just that, you know, this is an HTTP header and it can carry parameters. We need a way to have extensibility at the end of the day.
Or we need a strong reason not to have any extensibility.
Yeah, I think we would be really painting ourselves in a corner if we didn't have an extensibility mechanism in this specification.
No, you definitely want one. You can have a separate header, right? And just say I support ECN. Because here you're mixing up support of ECN and defining semantics for ECN. because you need to define all the four states for ECN correctly to make this work. While it's always clear that if you want to use ECN, you need 4 code points.
But you need to say which is which. And so this is a list, and maybe the property that we didn't forgot to mention, HTTP headers can be reordered. The ordering of HTTP headers doesn't have a semantic, and also structured field lists can be encoded as separate headers. Therefore, the ordering of a list has no semantics. That is not something we can choose. That is a property of HTTP. And that's why you can't just tell the extension, use them in this order, and you need a way to annotate them individually. And from my response to Victor, so the ECN extension has a separate header.
You don't need, because
time check here, folks. The queue has been cut. David, would you mind taking the rest of that explanation to the list?
All right, Maria, let's take this off list. Yeah. Oh, sorry. Let's take this offline and onto the list.
And yeah, I'm a little bit sorry here because I think we're about to understand each other, but not quite there.
Okay, let's go back to the presentation, which would be a lovely slide that will make the chairs happy. Slide 10, please. Yes. Do we think we can pick an option? So if we agree to keep this datagram flow ID header, are we able to pick a format? So I think of the 3 options we presented here, there's probably a 4th, which is the 0th option, which is do nothing. But based on the previous interim and some of the discussion here, I don't think anyone would be in favor of that. But it's something to consider. But the options here are what are presented. So option 1 is to require extensions to effectively define a parameter name of their own, and then some of the values that they support, or some of the variants. I don't know what we want to call those things, but it would look like that. Option 2 is that we define a common name parameter, and then extensions could just define their own names in their own specifications as they need, and that we can create some language that describes how a server or whatever would read that name and decide to do things. And then option 3 is this default thing. So yes, do we want to raise some hands, chairs? How do we run an assessment of these options, or do people think they want none of them? I don't quite know the best to gauge things.
Well, quickly, Ben is in the queue. I don't know if he has a clarifying question or something. Ben?
Based on the Jabber thread, I don't think that we are anywhere close to consensus on what should happen here generally. So I don't think we should spend time trying to do a consensus call.
Yeah, I think I would agree with that. I think the issue exists. I think we need to take this to the list for more discussion, and we can resolve it at that point. We will certainly do a consensus call, but
I'll take an action item to write up the options and bring that to the list soon.
Thank you, David.
Cool. Okay. So moving on quickly, the final issue we have is about flow ID reuse. So this issue is created by Martin Seaman. I think Eka created a similar one, so we coalesced them together just to say that the premise here is that flow IDs are carried in every frame, and that there could be some attraction to using small ones. We introduced some notion that the flow ID allocation service can support retiring and reuse of flow IDs, but that places some burden on application to tell the service when things are ready to be retired. And detecting when it's suitable or safe to retire or reuse can be hard. And so there's a risk that recycled flow IDs are used incorrectly with all the bad stuff that could happen from that. So we nominally have a flow ID that's a 62-bit integer, although not all of the space is available. But the question here is, we've got enough numbers. Do we really need all this potential complexity and risk in order to save some bytes? From some of the opinions we've seen and heard, we probably look at dropping this thing just so we could make progress. But the question to the working group would be, is anyone opposed to dropping this feature? Does anyone really want OID reuse to stay in the document?
Before we turn it over, please try and keep the comments and questions very short, clarifying if at best. Yeah, Tommy.
Yeah, I just want to say I think we should not have any of this retire reuse stuff. It adds a lot of complexity. I don't think it has any particular value. And I just want to point out, like, that is reuse after retirement should be distinct from allowing extensions to use numbers how they want, right? Like, I think we should not have this feature. We shouldn't have any constraints, though, necessarily on what an extension wants to do with the meaning of this arbitrary value that they have. It's not a flow ID.
Yeah, this is specifically about the concept of retiring. I mean, we've heard kind of overwhelming support on the issue to just remove this feature entirely, and maybe someone can add it later as an extension. So we're inclined to just do that unless someone wants to object loudly. Ben?
Yeah, I think reuse sounds insecure. It's one thing to allow an adversary to create replays of packets within a single context. Enabling replays across contexts sounds much more dangerous.
Yeah. Okay, then everyone, all right, if everyone's in agreement, let's just remove it.
Yeah, Ian, do you have a clarifying question?
I have a question. I think we should remove it totally. How are we going to enforce this? If we,
how are we going to
enforce it, but it's not trivial without requiring, say, flow IDs be allocated in sequence order or so on and so forth.
Can I ask you to file an issue for that, Ian, please? That's a reasonable question.
Sure.
Thanks. All right. The editors will write a PR to just remove this and we'll be done. And for the record, it was one person who asked us to add this feature and we added it in, and then they filed the issue to ask us to remove it. So just make up your mind. But anyway, let's just remove it and move on. Everything's good.
All right. Yeah, thank you, Lucas.
Thanks for the time, everyone.
Yeah, I think that was incredibly productive. We have nice. Certainly have what seems to be consensus on both design premises, and we can flesh out the formatting issues later on in the list. We'll confirm everything on the list as well. So David, hand it over to you. Please be quick as possible.
All right, I will be as quick as possible. So hi everyone, I'm David Skenazy. And I will say hi to all Mask enthusiasts and Martin Thompson, who's decided he is not enthusiastic about anything. All right, then next slide. Perfect. Thank you. Also, for the record, Lucas totally copied all my memes. I'm kind of annoyed because he got to present before me, but I forget them. All right, so if you haven't been following Mask, Connect UDP is Connect for UDP, and it uses datagram frames. Next slide, please. All right, so we did an interop at the hackathon last week with 4 completely independent implementations, and it worked. So that was really great. So far, we only did interop over the datagram encoding of UDP packets, not the stream one. And if you look especially on the issues for the repository, that is more in flux, so that makes sense. And I think our next goal in terms of interop will be to really try the stream encodings to get a sense for how good the different options are. And for the folks that aren't on this interop matrix, that have quick implementations, please show up. It was surprisingly easy to add this support. And the more people we have, the better notion we can get for complexities of part of the spec. All right, thanks. Next slide. So this was brought up, if memory serves, by Kazuo about whether we need a setting for Connect UDP. In general, new HTTP methods do not require settings. like new HTTP methods are already an extension point in HTTP. And unlike the conversation we were having earlier about the datagram flow ID, which changes semantics, the method doesn't change the semantics of that header. It only changes semantics for the rest of the stream, and that's perfectly legal. The one problem that Kazuo identified is there are broken servers out there because this is the internet and everything is terrible. There are some servers that, so in theory, what you're supposed to do as a server in HTTP is you parse the headers, and then you decide what to do with it. And for example, if it's a post, you decide to wait for the fin on the stream to send that data to your backend or whatever. But there are a bunch, I don't know about a bunch. We don't have data here. There's some servers that will wait for the fin no matter what. It won't actually process the full settings frame until they get the fin. And that would completely break if for Connect UDP, but also for Connect. Like, this isn't a new thing. And so Kazuo proposed to add a setting to be able to handle those servers. And I see Kazuo in the queue, so please jump in. You just have to click the unmute, and there you go. And hold on, we can't hear you. You're unmuted, but I can't hear you. Maybe now it's better. Say something. Yes, now we can hear you.
Right. So the problem is not only with broken servers, but the servers are working according to spec. And in HTTP, servers are allowed to not send a response until it receives the entire request up to the end of the request body. But if we define a new tunneling scheme, then the request, the end of the request body never arrives to the server, and the server would simply wait forever. Eventually, the timeout would kick in, but the additional problem for Connect UDP is that the client would sending datagrams repeatedly because there's no response. So the timeout would even be delayed. So I think that the failure mode is not great. So I think we need to decide between if we are fine with negotiating the feature. And the downside is, as you said, it's about the feature sticking out. But I think we have a trade-off here.
Yeah, no, it's absolutely a trade-off because the impact of this breaking is like bad performance on the client. And then but in the other direction, like, should we be constraining ourselves because there's a broken server out there? Like, at some point we can't spend like does this mean that every new method is going to require a setting? And on the point of not sticking out, this starts to stick out a bit more because I mean, maybe the header would be, hey, I'm not a completely busted server, but so what do people think, Ben?
Yeah, it's not like you use Connect UDP with random hyperlinks that you followed across the web, right? Like, Connect UDP is as specific as like SSH. You know exactly which server you're connected to, and you know that it supports Connect UDP, or you wouldn't be trying it. So I don't think we need to worry about it.
Thanks, Ben. MT?
Agree with that. I think we absolutely have to worry about this. This is just another method to the server setting, and doesn't see the setting there. And so that server is going to do exactly the sorts of things that Kazuo was worried about. And that would be perfectly normal. It's not broken. It's working. And at that point, I think we're in a pretty terrible place. The setting doesn't stick out if you put it on every connection. If you're willing to do it in one place, then say that you're willing to do it everywhere. Just don't actually exercise that capability, and then you don't stick out at all. So it seems to me that cleaner is not just cleaner. It's we don't cause servers to break when they're doing the right thing.
So just actually as a clarification, Martin, And when you're saying the server is doing the right thing, are you saying that like not parsing the headers until you've received the fin on the stream is the right thing? Because that goes against the spec, doesn't it?
No, but it may be the case that the server is a proxy or a gateway or something like that and starts forwarding all of this stuff, and they might, I don't know. You're not seeing a content length, right? There's no expectation that the client's going to be setting a content length or anything like this in something like H3. And so it's just going to start forwarding stuff, and it may have some buffering rules that it needs to follow, and it does that. It's just going to sit there hanging. It's kind of, who knows?
Okay. Thanks.
Valid.
At this point, we're going to cut the queue. So, Jonah.
Thanks, David. I wanted to poke on the question on the point of sticking out just a bit, because I don't think I fully appreciate it. Can you say a bit more about what it means for this to stick out, and why is that a key problem here?
Absolutely. So that was one of the original, I mean, that was the goal of the first MASQUE proposal. I mean, MASQUE has evolved quite a bit since then. But the idea is behind MASQUE is we do a lot of cool features that aren't what you're traditionally used to from an HTTP server, but we make it look like regular HTTP. And what that means is, you know, especially as we go down the road with Connect IP and stuff, you can do magic VPN things for something that looks like the web. And so what I mean by sticking out is, let's say you have a web server that it just serves gets and posts, and you have a web server that gives you full VPN things. We want to prevent sensors from being able to probe the server and go, hey, do you speak MASQUE? Oh, you do. Okay, let's put your IP on a block list. And so that's what I mean by sticking out, where you don't notice necessarily that there's this magic functionality.
The only way you find out about that from a proxy is by actually trying to use MASQUE with that proxy. Isn't that right?
Well, that's the goal. So let's say if you, for example, you had a Connect IP, but then it would require an authentication header on that HTTP request. And if you have the header, and you'll get a 200, and if you don't, instead of saying access denied, it'll say, oh, unsupported method. I've never heard of what you're saying.
So I don't want to spend. Sorry, I interrupted you there.
Oh no! So then if that means that people can't probe. But then if you have I'm a MASQUE VPN server as a setting, then people can notice this even if they haven't authenticated. I think the key difference is you want to give this information to folks with the password and not to others. But if you want, maybe we should take this offline because we're a little short on
Yeah,
time.
I think it might be worth articulating this particular threat model a little more carefully, because I'm not sure how much of this is real, but that's where I'm coming from. But yes.
Okay, let's take this offline then.
Sure.
Philip, is this a scribe comment?
I was just going to say I'm astonished that we still have that fin stuff left in HTTP. I thought it had gone 25 years ago.
Nice. All right, thanks. Jonathan?
So I guess my question is, I mean, is this actually ever a case where I think it's sort of related to the question of, you don't connect TCP to random servers. Is this ever a case where, is it just that you get the failure, the correct behavior with these servers, you get the failure sooner rather than after the timeout? You get if we're just working around the fact that some servers will give you, timed out rather than unknown, timed out after 30 seconds rather than, unknown method immediately, I think that's not worth worrying about. You already know you're talking to the wrong server. You're talking to the wrong server. Knowing you're talking to the wrong server 30 seconds earlier is not a huge win. It's already a configuration error. Go fix it. So I think I would say don't worry about this, because if you're talking, unless there's some case where you'd expect that, like you have some proxy such that you'd actually successfully get a connect UDP if we're doing the right thing, and the settings were there. But if because it's broken, you don't. I don't see how that would work. So other than that, I don't see why this is worth worrying about.
Okay, thanks. What I'm getting here, and Chair's correct me if I'm wrong, is we have people with opinions on. You want to mute, Jonathan? We have people with opinions on both sides of this, so I don't think we're going to reach a resolution in the room today. So I'd say let's take it to the issue and move on to the next slide. All right. Oh, that's another fun one. So initially, Connect UDP didn't have a target URI or a scheme because I pretty much took the definition of Connect, copy pasted it, and slapped on UDP in there. Then people rightfully commented that you're not allowed to do that in HTTP. The semantics say that all methods, with the exception of Connect, but that exception doesn't apply to new methods, need a scheme and a path. So let's just add a scheme and a path. The path is / done, have a nice day. The scheme, it really, in my opinion, it is completely pointless. This is just to be compliant with some existing specifications. And so at first I created a mask scheme, and then folks were telling me that, oh, you can't just do that. That's a lot more work, and work for no benefit is not something I like to do. So then I said, like, how about we just use HTTPS? Like, the scheme is completely useless. It will not be acted on by anyone. But if we need a value in there and it needs to not be empty, what's the downside of using HTTPS? Thoughts, comments, questions? Ted.
First off, I think this is a total bike shed. So the color of your bike shed painting is not very important, but I think it's a little bit. Martin Thompson points out that there are 2 UDP schemes and we should have a third. I think that's the point of his comment anyway. Since this is not really used, we can use either UDP scheme and get the same results, right? So I would use UDP here just because it's a bike shed.
I agree. I honestly don't care as long as you don't have to. I don't have to jump through 17 hoops to get the new scheme overlords in their good graces. Kazuo?
Assuming that we agree on using a settings frame, I would point out that we already have a way of negotiating a tunnel that can handle arbitrary protocol, and that's RFC 8441. So assuming that we go with extending settings, I don't think we need a new negotiation scheme for this. Simply choose a scheme name and use a connect method. That's enough.
So that's an other design decision, which I thought we had reached agreement on, where we could have used extended connect with a protocol, but we decided to go with connect UDP instead. I don't think there's too much interest in revisiting that, because that's also a bike shed. At the end of the day, they're completely isomorphic, but I'd rather just stick with this for now, just because we agreed on this like last year at some point, I think.
Well, I think my argument is that that decision was based on the assumption that we wouldn't use using settings.
All right, so maybe we need to put a pin in this until we've reached consensus on the previous slide. So maybe we'll take this one also to the list/issue, which right now the 2 are on the same issue number 23, which we should probably split it up because it's kind of a mess, but I can take care of that. Tommy?
Yeah, I just wanted to bring up something I think I brought up at the interim. Do you think we need to have this document specify the specific scheme you need to use? Like, we can say you must have a scheme. Do we need to mandate what it is? I don't think other methods mandate what scheme you must use with them. Like, get or any of the other ones. So can we just make it not our problem?
That would equally be totally fine to me. I remember some people having strong opinions against that when you proposed it on the issue. And I am seeing all sorts of various amusing scheme proposals here, left and right here. Thanks, everyone. All right, let's maybe take this to the issue, and maybe we should consult with the HTTP working group to see what is legit, because I know they have strong opinions there. Because I honestly don't care what the color of the bike shed is, as long as I don't have to spend a lot of money on the paint.
So let's split it out into its own issue so that we can track it separately, and then we can bring it to HTTP as necessary.
All right, let's do that. All right, or Jana, you have a quick thing on this one before we move on?
Yeah, I want to raise a third option, which is to basically completely punt this out entirely from this, which is to say that the receiver, if it receives a scheme, ignores it entirely, and so therefore we don't care what the sender sends. Why
I think that's exactly what Tommy just proposed.
Okay.
Let's take it to the issue.
Yep.
All right. This actually, so I have a few more. Well, let's see. How many slides do I have? Like, this is 6. All right. How about this? We're really short on time, and I want to leave time for the other presentations. I'm gonna quickly present these, but maybe maybe let's say keep the discussion on the list or on the issue as opposed to here, so we can leave time for the other presentations. So very quickly here, or Jairus, how does that sound?
Let's do it.
That sounds great.
Okay. Okay, cool. All right. So here, right now, the negotiation is done at the start of the stream in the datagram flow ID header. Some folks were saying, well, it would be cool if we could negotiate them like halfway through a stream. Yeah, it would be cool. And there are some advantages for doing that. There are some downsides because, like, well, added complexity in the protocol, but also added complexity in intermediary implementation. So my personal take is maybe let's not tackle this for now. We can handle this with an extension later. But if you have opinions, please come to the issue. Next slide. And so similarly, right now, the stream encoding uses what I've called chunk types, which have their own IANA registry. Tommy proposes to instead using the flow IDs. That has the advantage of not having 2 separate namespaces, but it adds some other complexities for cases where you don't have flow IDs, for example, or what it means for intermediaries. I mean, like, the more we talk about it, the more I'm not sure. So I would say let's punt this for now. Let's implement one of those things, either or both, and see how it feels to implement them to make an informed decision. But again, please come to the issue if you have thoughts. Next slide, please. Connection migration. So if you're doing quick over mask over quick, or sorry, quick over connect UDP, you can end up in a situation where the mask connection, by which I mean the one where the connect UDP request goes over, is migrating, and that one will reset its congestion controller in response to migration. The inner, encapsulated or tunneled, however you want to call it, end-to-end quick connection will not necessarily notice this migration. The client will notice, but the target server won't actually know that it happened. So it might send a full window of data, which then the intermediate, or the proxy, sorry, is going to get it. And then it's not going to be able to put it on datagram frames because those are protected by congestion control. So it's going to drop them on the floor. We should definitely add some text to do this. And we might have some ideas of mitigation, such as maybe the proxy should switch its target-facing port to make the server realize that a port migration happened. Again, this is tricky, and I'm sure there are a lot of implications. So please bring thoughts, ideas, suggestions to the issue. And next slide, please, which should bring me to the end of my slides. Yes, this is all the slides I had for today. Thank you very much. And Dallas, you're up.
Okay. Hi, everyone. I'm Dallas McCall, and I'll be talking about MASQUE IP proxying requirements today. So if you can move to the next slide, I'd like to start with discussing like a few fundamental features of the requirements. And then time permitting, I'd also like to discuss some of the open issues that we have. So the first one, which seems quite existential, is let's go ahead and agree on what we mean when we're talking about IP proxying. In the current requirements document that we have posted, we're discussing proxying IP packets, including the header. Alternatively, there's been the suggestion of proxying IP payloads, which would include sending the metadata for the actual flows through some side channel. I'd like to go back and kind of look at the use cases that we're discussing for both of these, and the trivial use case where we're discussing connecting basically one flow with like one IP endpoint on either end is just as easy, I would argue, using approach 1 here or approach 2. That said, I think that the VPN approach, the approach 1, is much simpler in the case where we're considering multiple flows. So say like in a client to network VPN where you have some clients sending flows to 100 different backends, being able to keep track of that metadata seems rather expensive. So the proposal here is, can we go with 1 and then ensure that we have extensions available to be able to enable this IP payload as an optimization? I'd like to leave this open to any questions or discussion. Mira?
Yeah, thanks for putting this down this way. That really makes sense to me. So the point about option 2 is actually that we are kind of already halfway there, because it's very similar to Connect UDP. Like if you take Connect UDP and you add like a little bit to it, then you get the same thing for IP proxying. So somehow I have the feeling we maybe need both, or we want both, and maybe want to go, we don't want to say like do one first and then later on the other, because both of them might not be very complicated. But I also can't give you a final answer right now.
Okay, Alex, do you have a response to that?
Yeah, I just want to say that I don't think it is fair to use the existence of another draft in order to inform the requirements of a different one, because we can also just as easily say, just as we have the Connect UDP draft, we also have an implementation that currently does the more VPN style thing within Google and partly also open sourced. So I don't think that for a requirements document, we can immediately use the existence of running code, because honestly, if we do, then it also very strongly favors the current approach that is already in the proxying requirements.
Okay.
I just, yeah, so I think I was just talking about, what's the solution we want to see here. And I'm not sure what the right one is. But for the requirements document, I actually want a document that doesn't favor any of the two solutions and just keeps that open for a later decision when we actually know what it means to implement one or the other solution and how complicated it is. So I think the requirement should be as neutral as possible. And anything that would favor one of the other solution should be defined as something that's optional or not required, or not mandatory. That's the right word.
Yeah, so I think we might kind of be agreeing. So the point that I'm trying to get across is that the thing that we want to define requirements for is, on one side of this proxy, feed in IP packets, and on the far side of this proxy, send out IP packets. And so the whether or not we strip off the headers and put them onto something else and then recombobulate them on the far side seems like sort of an implementation detail, and that's kind of why I was hoping that we'd be able to sort of at the level of the requirements just say all we're doing is taking IP packets from one side to the other side, and then we should have the extension knobs to be able to munge those packets in some useful way, such as this where we're compressing the headers. But that seems kind of like a further detail.
Yeah, fully agree. And I think for the base kind of forwarding requirement, that's what we already did with the text change from the last time. We just have to make sure the other requirements are also on the same level here.
Okay. It looks like there's a few more people in the queue. Benjamin?
Hey, I think there are several requirements that I want to capture here. One of them is this transport needs to be lossless for any IP packet present or future. That tightly constrains a lot of the kinds of encodings that we're talking about.
Sorry, did you say loss, Ben?
Let me try that again. I said lossless. Like a lot of the, it's very common for anything that tries to proxy an IP payload with metadata by side channels is going to be trying to re-encode, essentially create a compression format for IP packets. It's very easy to turn that into a lossy compression format accidentally because there's an unlimited space of potential future variability. It's ossifying if you're not very careful to stick to the invariants provided by the underlying format. So I think
can I jump in real quick? Okay. There is a later requirement which is not discussed on this in this slide deck about optionally having reliable retransmission and using H2/H3 streams. So
that's
you
not
can
what I'm talking about.
Hold on, Alex. That's when he said lossless. Now I found that's why it got me confused as well. It's not lossless in the sense of packet loss. It's lossless instead of fidelity loss in compression. And I think maybe if I can slightly restate what you said, Ben, to clarify, is if we have something that just compresses, then you can fall into this trap. Whereas if we do something that by default sends full payloads, then that trap doesn't exist. Right. Is that right?
Cool. Right. This is why in Do we ended up shipping entire DNS UDP formatted payloads in base64 in URLs rather than risk trying to re-encode the information and end up introducing a conversion loss.
Cool.
I think there's also an implementation simplicity requirement. Like if we end up with something that's tremendously complicated to implement, that's very challenging. As a VPN implementer, shipping IP blobs around without having to look inside them is strongly preferable. And also there's another requirement here that I think has been missing a lot from this discussion, which is MTU consistency. We just recently had an issue where a slight miscalculation in the MTU expectations of DTLS SCTP resulted in a user-facing outage because we didn't quite get it right. Having variable overheads is pretty scary. We already have some of that, but let's not make it worse.
Cool. Thanks, Ben. So I actually want to underscore a little bit what Ben said. And having implemented an IP tunnel in a previous life between Apple Watch and iPhone, actually, with compression, the big learning there was that a design that takes the fields it wants and sends them is what Ben was calling lossy. It can cause serious problems if something happens that you didn't think of. Whereas the design that we eventually landed on that worked really well was by default, you send uncompressed. And if you see something that your compressor knows that it can compress in a way with 100% fidelity, then it compresses, but you always have the escape hatch of sending uncompressed. And I think that is an important design decision. And that's kind of one of the things we reflect here with option 1. You proxy IP packets. We can talk about compression later. Maybe it's in the core spec, maybe it's in extensions, but the core fundamental property is that we proxy IP packets. And another point I'd like to make is to strongly disagree with Miria's point, which is Miria said that the requirements document shouldn't be opinionated here. and should allow both. We can't do that. Like, the point of this requirements document is to guide what we're going to build. And so if we can't agree on what mask IP proxying means, we're never going to get anywhere. Or the requirements document is not going to be useful. So my personal, as an individual take here, is that we really should agree on what this means and what IP proxying is, and we built that. We're not saying that mask won't build the option 2 at some point in the future. Who knows? Like, that can always happen later. But for now, it would be nice to get a requirements doc out the door with option 1, and that way we can start building a protocol for it. I think that is really the best way forward. That's it. Ecker?
Yeah, and I think I largely agree with what David just said. I think the fundamental feature here is like IP packets come in and IP packets go out, and that's what needs to happen. And like and then and then some very vague like words about like what in the middle, like what to like with the addendum that Ben made that any IP packets go in and any IP packets go out. And then some very vague words about like maybe some nice things about what might happen in the middle that are like engineering guidelines, as in shouldn't be too complicated and maybe shouldn't be taking too much CPU or whatever, right? I guess I am starting to wonder, frankly, if we've like outlived the usefulness of this requirements exercise. I think this is really done in an attempt to script the problem, but I'm now starting to feel like this is like becoming proxy arguments about what the protocol will look like in the end. I do think this point we should resolve in favor of point 1 here, but I also think perhaps we should just say like, hey, this document is kind of like done this kind of thing. I certainly do not think that like that the external interface should be somehow proxying things that are not IP datagrams on the in or the out of the pipe. At least not for the initial thing.
Yeah, cool. Yeah. Thanks, Eric. Mike?
Hearing a lot of opinions on the question being asked on the slide being presented as statements of fact. So we don't, what we're trying to build is essentially a black box. The future design, yes, it's a black box as to what happens between the client and the proxy. The requirements draft is trying to talk about inputs and outputs of the black box. And we should absolutely be agnostic about what's happening inside it, but we cannot be agnostic about what's entering and exiting. So we need to decide, are we supporting arbitrary IP header options? Are we supporting arbitrary IP versions across this tunnel? Like if there's an IPv10, should it be able to transit this? We make that decision. We write it down in the requirements draft and we move on. We don't have to design the inside, but this is not designing the inside.
All right, we're going to cut the queue here and see if we can wrap things up on this. I do think the point about requirements versus proxy discussions around versus a discussion around what we think we actually want as an implementation is well taken. So let's try to keep a focus on, the second bullet here says some use cases can be implemented with either. If there are use cases that cannot be implemented with either, I think that would be the thing to bring up right now.
Maria, you want to go ahead?
Yeah, I do agree that there should be an option where you can like put packets in, IP packets in, and you get the same IP packet out at the other end. But there are also use cases where it's actually unnecessary to create the whole IP header when you just create the payload, and you can create the IP header later at the proxy, and that just saves you some overhead, that saves you some bytes. And all I want is that we don't preclude to have this option. However, it looks like I think compression is actually the wrong term. I brought it up a couple of meetings ago, but it's not the right term here. It's just like you don't even create the IP header at the input because you don't need to. So I don't want to preclude in the requirements that we also can easily support this case. And I can well imagine that we come up with a solution where both is easily possible without a lot of overhead.
So my understanding of one here, Miria, is that it doesn't preclude this case. You can, at some point, later, either, again, it can be in the core protocol, but most likely an extension, say, okay, I don't want to be transmitting the IP header, or I don't want to be building the IP header. I mean, at the end of the day, that the fact that you built an IP header that you chose not to send, or you just didn't build it, is an implementation detail that has no impact on the protocol. So I don't think that's something we need to discuss at all. And in terms of what impacts the protocol, proposal 1 here totally solves this, unless you have a use case that it wouldn't solve.
So when you talk about proposal, that's kind of the design you have in your mind, right?
I'm sorry?
That's because you have a certain design in your mind. I'm just talking about from requirement sides. I just want to not preclude this case where you don't have to build the IP header. That's all I want. How the design looks, I agree with you that I think the design is very, very similar and like not far away and more or less easy to achieve.
Miria, I feel like you're belaboring the point. We have repeatedly said that your case
There's a queue. Please follow the queue.
Or protocol. We are all in agreement here.
No, I didn't understand what you said because I guess Eric was talking over you. Sorry.
Yes, we have a queue. Please follow the queue.
So then David can repeat what Alex said.
Sorry, just I think Alex is saying that we're in agreement that what you're saying, it can be implemented there, and it's just the only point of disagreement between you and I think here is that what should the requirements document say, and having a specific architecture choice is, I think, important in a requirements document, because if we can't even think about what the architecture it is we're building, then what is the point of a requirements document? Because we thought, the 3 authors, when we wrote this, we took this as an axiomatic. We thought that it was clear that we were forwarding IP packets, and based on some discussions with you, we realized that that wasn't an obvious statement. And that's why we want to reach to have this discussion in the working group and reach consensus on the overall architectural bit, which is, max IP proxying means we proxy IP packets. And I mean, I understand that you disagree with that, but I'm getting a sense that the authors aren't alone in thinking that this is a reasonable architecture choice.
So it doesn't matter if that's a reasonable architecture choice. I don't think you should make the architecture choice in the requirements document. And I agree with Eka that we probably got over the point where this requirement discussion is useful and we have to talk about mechanisms. So I don't think we are totally disagreeing here. We just have a different understanding about what a requirement document should be.
Okay, that's totally fair. Thank you. Magnus?
Yes. So I do think the requirements document is maybe not requirements. It's maybe not clear on the requirements on the IP protocol level, and I think we still have the question here, I think, in some degree on how much router functionality in this protocol should be, because the site-to-site seem to require some router functionality in the endpoints, and how that interacts with the rest of the network.
So on the topic of router function, actually, we have some slides later, and I think that's a separate question from this one. So if we could maybe put a pin in that until then, if that's okay.
Sure.
Yes. And speaking of, if you can move along to the next slide, I think that's about where we can talk about that.
Actually, Dallas, what we'd like to do at this point is do a hum between option 1 and 2, just to really nail this down, and then confirm on the list, because we have been sort of floating around these 2 different proposals for a while now. And we just like to get consensus. So what I'm going to do now is do a show of hands for option 1 and then option 2. So start with option 1. Just take a moment to fill it out. Okay. So the results are in. I'm just going to flip it around now. Here you go. Okay. So it sounds like most people are in favor of option 1, but there was also some support for option 2. Well, we'll confirm it's all on the list, but it sounds like things are leaning in a particular way. Dallas, I can flip it back to you, but note that we're at the top of the hour and mostly out of time. So I guess a quick question before we start here. Yeah. Is this something we can discuss on the list, or do you need airtime right now? Because
this is going to take more than 1 minute to discuss, so maybe let's move it to the list.
All right, great. That's fine. So we'll do that.
In addition to the list, perhaps an interim, so we can keep the conversation going in the near future. Would that be a good idea?
Yeah, thank you. I was just going to say that. We're as is per mass tradition now, we're going to have an interim likely soon, so you should see a doodle poll go out with times between now and IETF 11. May do one or more than one, depending on how much work needs to get done, but hopefully we can resolve some of these issues then and continue progress. So Eric, do you have anything to say before we wrap up?
Just a thank you to our scribes and note takers and such. If there's anything that, as we talk about requirements, it really is time to start making some decisions and moving forwards beyond requirements to what we're actually going to do. So we are talking about packets and payloads, and can we do both? Should we do one? Does that even belong in requirements? The thing that I think would be most helpful is if we can detail the use cases that we cannot do with either, that would require both or one or the other. So if folks have those use cases, there was a decidedly mixed result on payloads, despite packets having fairly strong support. So please, please, please bring that use case description to the list so that we can be done with requirements and move on.
Yeah, well said, Eric. All right. With that, thank you all very much for your time and discussion, and we'll see you at the interim.
Thanks, everyone. Have a great day.